All right, we will go ahead and get started with 3.7. So we're going to cover 3.7 and then get through as much of the review as we can. Now, I did have several questions in the other class about the weather. So if campus is opened, I will be here Friday to finish the review. Obviously, there's no reason if y'all want to stay and Zoom from home, or if the weather's bad for some reason. If the weather's bad, they're not going to open the campus. It won't happen. They close because this is a commuter campus. There's people that come in from Cabot and Bryant and everywhere in between. So if any of those schools are closed, they will close us. So if this does occur, and I know that they're predicting ice and not snow, which could mean that there will be power outages, and y'all do have a test due Sunday. I'm going to keep the test open. It is open right now and due on Sunday. However, if you do have a power outage and you cannot do your test, there's absolutely nothing you or I can do about that. And all you have to do is let me know and I can extend your due date. What I'll probably do on Monday is go through and see who all didn't take the test, which just means that I'm not going to try and pick through the reasons with you of why it didn't get done. So I'll probably just send an email to those people saying they get a couple of extra days to do it. Okay, so again, if we are open, I think the main weather is supposed to hit tonight and tomorrow morning, maybe. I don't know. So it doesn't look good for tomorrow, but I'm not sure about Friday. I don't know if the temperature is going to go up high enough to melt everything. I don't know. But if campus is open, we will have class Friday. If you just want to Zoom from home, that's fine. So everything's going to stay the same right now, and then we'll just play it by ear. We can't control the weather, but we can control due dates. So we'll just play that, see how it goes. Okay. All right. 3.7 is on graphing linear inequalities, which means instead of graphing equal signs like y equals x plus 2, we're going to be graphing y is greater than or y is less than x plus 2. Now, before we get into drawing these lines and shading where we're supposed to shade, here are the rules. When you are doing greater than, less than problems, sometimes your points are connected with a solid line, just like always, just like your y equals, but sometimes they are connected with a dashed line. So what tells you the difference between those two things is whether or not it has this equal to bar. If it has the equal to bar, it is going to use the standard solid line. If it doesn't have the equal to bar, it is going to be connecting the points with a dashed line. And I will share my screen in a minute and show you how to tell MathLab, because what MathLab does is if you plot 2 points, it's just automatically going to default to connecting them with a solid line. You will have to physically go and tell it you want to change it from a solid line to a dashed line on the ones that need to be dashed. Also, when you're talking about greater than or less than, part of the graph is going to be shaded. If yours says greater than, y is greater than your line, you are going to shade above it. If y is less than your line, that's telling you where are the y values less than your line, you are going to shade below it. Okay, so let's look at a couple of these. On number 1, we have y is greater than x minus 4. So just like always, you're going to want to go to your y equals, because in order to graph on MathLab, you're going to have to give it 2 points, right? Okay, so we're going to need to come up with 2 points that are on this line to be able to graph it. The easiest way to do that is to go to your y equals and clear out whatever's in there. And just like always, the y is by itself, so you just need to type in x minus 4. So type it in your x button minus 4. If you want to see what it's going to look like, hit your graph. My main thing is I need to get 2 points. So I'll hit second table and then just pick any of those points from my table. Any of them I want. So let's see. I'll do -1, -5, and 1, -3. Again, I just picked 2 random points out of this table. So you'll plot them. So let's see, my first point is at -1, -5, which would tell me to go left 1, down 5. Left 1, down 1, 2, 3, 4, 5. Put a point. Then my next point would be at 1, -3. So to the right 1 and down 3. So right 1, down 1, 2, 3. Now, when you do that in Math Lab, like I said, it's going to automatically connect those 2 points with a solid line. So what I would have to tell this one, since it doesn't have the equal to bar, no equal to bar means a dashed line. So you actually want your line to be dashed. Again, I'm going to share my screen in a second and show you how that happens, how you turn it from solid to dashed. Now you're also going to have to shade it. So let's see, y is, if your arrow is pointing to the right like this, that says y is greater than. So where are the y values greater than this line? If it's greater than, you are always going to shade above. Okay, so I am going to share my screen on this just to do number 1, just to show you the 2 things on how to change your line from solid to dashed, and also how to shade. We go to 3, 7. Number 1. So this one is y equals x minus 6. So let's see, I would go to, again, go to your y equals, it's not sharing? It says I'm screen sharing. Oh, that part of it. So it brings up that, just not the problem. Okay, hang on. I'm going to stop. I'm going to do something different. Now what about that? Okay. So I have y is greater than x minus 6. So I'm going to go to my y equals and put in x minus 6 this time. And then do second table and pick out 2 points. So let's see, I'll do 0, -6, and 1, -5. So I'm just choosing 2 points out of this table, 0, -6, and 1, -5. So I'm going to click to enlarge graph. Did it do that? Okay. Go over here, tell it, first thing you have to tell it is that you want it to be a line. So there's your line tool. And then plot 2 points. So like I said, I'm going to do 0, -6. Now remember, up here in the top in that yellow rectangle, it'll tell you where your cursor is. So I need 0, -6, and 1, -5. So you'll notice when I connect it, when I put that second point, it connected it with a solid yellow line, which means if this had the equal to bar, you would just leave it solid. But if you come over here in this tool palette, look over here, right above the word delete is that little dashed line. So when you click on that, it turns that yellow line dashed. So again, right above the word delete will be a picture of a dashed line. So you just click on that. And see how right above it is a solid line. So when you click solid line, it makes it solid. When you click dashed line, it makes it dashed. Now, I'm also going to have to do what else? I'm going to have to shade above that line. Is it above? Yeah. Shade above that line. Which means what you're going to do, see this little paint can? You click on that. It's called the region shading tool. I'll click on that paint can. And then you can put this paint can anywhere you want as long as it is above the line. Not below it, but above it. If you are anywhere, it's going to shade everywhere on that side of the line once you click. So once you click, it'll shade that whole side of the line. Okay, so again, you may have to change your line to dashed, and then you use the paint can to shade. And you just put the paint can either above the line or below the line, depending on which side of it you're trying to shade. Okay? All right, let's look at number 2. (5x minus 3y is less than or equal to -9. Okay? So before we can go to y equals and get our points, we have to get the y by itself. So the first thing I have to do is subtract the 5x from both sides. So here, now I've got -3y is less than or equal to. On that right side, that can't, one's an x and one's not, right? So they don't go in the same basket. They stay as 2 separate terms. Doesn't matter who comes in front of the other. I always just put my x in the front because I like the way it looks. So I'm going to put my -5x in the front and then my -9 in the back. My next step to get y by itself is I'm going to have to divide everybody by -3. Now, when you are dealing with inequalities and you divide both sides of the inequality by a negative, this symbol turns around. Oh, no, y'all can't see that. So when you divide both sides by a negative, the inequality symbol turns around. So now I'm going to have y. So the arrow was pointing to the left, which means now it's going to go to the right to turn to greater than or equal to. Negative over negative turns that to +5/3 x. -9 divided by -3 is a +3. That's what's going to go now in your y equals so that you can find your 2 points. So again, trying to get my 2 points to plot. So I go to y equals, clear it out. Type in 5 divided by 3x plus 3. And then I'm going to hit second table and pick out some points. I'm obviously going to stay away from any point that's got a 0.667, right? Any points that have decimals, if at all possible, just avoid them. So I'll use this one. -3, -2, and this one, 0, 3. Again, just picking points that are pretty. So let's plot those. And then the two things you're going to have to decide is solid or dashed, and where do I shade? So -3, -2 will be left 3, down 2. So left 3, down 2. Zero, 3. So my x is 0, so I'm not going to go left or right at all. I'm just going up 3. Again, once you do it in MATLAB, it's automatically going to connect it with a solid line, which this time that's what I want, right? Since it has the equal to bar, that's what's telling me a solid line. And since it's pointing to the right, it's greater than. So where are the y values greater than or bigger than this line? They are greater than it, above it. All right, number 3. I'm actually going to do number 3 and number 4 together. Number 3 says x is greater than 4. And number 4 says y is less than or equal to -1. Now, the reason I'm doing these two together is because they are special lines, okay? If you'll notice, most of the lines that we graph have an x and a y somewhere in the equation or the inequalities, right? They have both. They have an x and a y. You'll notice that this one, first of all, this one doesn't even have a y, which means I can't go to my y equals because I can't get y by itself because there is no y. So that one's special. This one's also special, even though it does have a y, and I can go to y equals to graph that. This one doesn't have an x like most of them do. Okay? If that is the case, all lines that just are x equals are going to be vertical. If it's a y without an x, it's going to be horizontal, and here is why. So I'm essentially going to graph the line x equals 4. So what that's telling me is no matter where I put a point on this line, the x coordinate of the point has to be 4. So if you're cheating, which is not really cheating, and you're looking up in the yellow rectangle, when you're plotting your points, this one has to be a 4. It doesn't matter what your y is. It can be anything. As long as x is 4. So this is why it makes a vertical line. What does your x coordinate being 4 tell you that your point has done? You've gone to the right 4. So if I've gone to the right 4, there's one spot I've gone to the right 4. I'm going to have to find another spot that I've gone to the right 4. There's an infinity amount of points that you can choose from. Well, I guess it's limited to how big your coordinate plane is. But if you've gone to the right 4, you are to the right 4 from this right here, right? You've got the y's are changing depending on how far up or down your point is. The y is going to be changing to all different numbers. But if you've gone to the right 4, your x coordinate will be 4, and that's what this is saying. Now, it's going to see why it's going to make a vertical line, because if you connect those, it'll be straight up and down. It does need to be dashed, though, since there's not an equal to bar. And I do have to shade it. It's just that usually we talk about shading above or below the line, but if you're vertical, you can't go above it or below it. But what does this say? Where are the x values greater than 4? Here's where x is 4. Here's x is 3. Here's x is 5. Everywhere this way, your x is going to be bigger than 4, right? So you're shading to the right of that line. That's where the x value is greater than 4. So this one should make a horizontal line. Let's see why. This time when I'm moving around, I don't care what x is. This just says y has to be -1. Well, what does y being -1 tell you about your point? That it has gone down 1. So if I go down 1, here's the most obvious place down 1 is. But there's millions of places that are down 1. Even if I'm way over here, if I'm still down 1, my y will still be -1. Or if I'm just right next to it. If I'm still down 1, my y will still be -1. Now, so that's why it makes a horizontal line, the one that goes straight left and right. It's not slanted. This one is a solid line, right? Since it does have the equal to bar, so I don't need to change it to dashed. It will be solid. Where are the y values less than -1? Less than means shade below. All right, and the last one for this section, before we start the review, has 2 of them together. Okay, it is multiple choice, but I'm going to show you how to distinguish between all the 4 graphs. So y is greater than or equal to x plus 3. And y is less than or equal to 2 minus x. So if you notice in this multiple choice, the lines on every single one of them are actually the same exact lines. The only thing that's different between A, B, C, and D is the shaded portion. So what you do is you graph each one of these separately, do their individual shading, but the answer wants to know where does their shading overlap each other. Okay, so let's graph the first one, y equals x plus 3, and I'll graph it blue. So again, you can just go into y equals, type in x plus 3. Get 2 points, so go to second table, and I'll just pick out 2 points. So -5, -2. -4, -1. So again, I'm going to do this one blue. -5, -2 will be to the left. 5 down 2. -4, -1. So left 4 down 1. It's got the equal to bar. So I'm going to do it solid. And it wants to know, since my arrow's pointing to the right, I'm going to shade above, right? So all of this area is shaded blue. Now I'm going to graph the other line in green. So again, I'll go back to my y equals, clear it out, and I'll put in 2 minus x this time. So 2 minus x, get 2 points there. So second table to get 2 points, and I'll do these in green. Let's see, I'm going to do these down here. 0, 2, and 1, 1. So again, I'm just picking out any ones I want. What did I say? 0, 2, and 1, 1. So let's see, 0, 2, left and right 0, up 2. 1, 1 will be to the right 1 and up 1. Has the equal to bar, so it's going to be a solid line. And y is, the arrow's pointing to the left. Left means less than, so the green is going to be shaded below the green line. So all of this is shaded green, which means which area of this has the both shading, blue and green, which would be in this area right here, right? That's where it's blue and green. So that's how you tell that multiple choice. There's only one that has it shaded over on the left side, which is that C, where it has, that's the only part that you'll see shaded. Okay, now I'm going to start the review for test 1. Now, when you're doing the review and the test are going to be so similar. What's going to change mainly are the numbers of the problems. So the review and the test have different rules. The review, you'll be able to take an unlimited amount of times. You can take it as many times as you want. Now, it's not like the homework, because remember the homework, if you get it wrong, it tells you immediately and lets you try it again. On this review, you have to work every problem and hit submit before you'll know which ones, and it gives you a grade, before you know which ones you got right and wrong. Now, you can do the whole, and if you want to improve your grade, you take the whole review over again. So again, you have unlimited attempts to do the review. The test, which will be laid out exactly like the review, you only have one attempt, okay? So what a lot of people that do well do is they do the review until they get the grade that they would like to get on the test, right? If you take the review once and you get a 50, you're not ready. That means go through, it'll tell you which ones you got wrong, and then look at those kind of problems to figure out what you did wrong, okay? And then retake it to see if you can improve your review, okay? All right, so let's look at this review for test 1. Let me see. So this goes all the way back to the beginning of school. The very first section that we covered actually does a lot that we were just doing here. It's by plotting, graphing, by plotting points. So number 1 says graph the equation by plotting points. You have 6y plus 3x equals 6. So just like we did in the section that we just covered, we need to get y by itself so that we can go to our y equals, put the equation in, find 2 points, and plot them. So let's see, getting y by itself. The first thing I need to do is get rid of the 3x. So I'll subtract 3x from both sides. So now I have 6y equals, again, these can't go in the same basket because one's an x and one isn't. I always like to put my x in front. It doesn't matter. So I put the negative 3x in front and then the plus 6 in the back. Still getting y by itself, so I will divide both sides by 6. So now I have y equals, that'll reduce to negative 1/2 x plus 6 over 6 will be 1. So that is what you're going to type into your y equals so that you can come up with your points. So go to y equals, clear it out, type in exactly what it says. So negative 1 divided by 2x plus 1. Now remember, this was that section where we graphed all different shapes. Some of them were lines, some of them were U's, some of them were V's, some of them had kind of like a squiggle shape. So go ahead and graph it first, because remember, before you do anything in Math Lab, is you're going to have to tell it what shape you're about to graph. So I definitely know it's going to be a line, which means I'll just choose the line tool when I'm graphing in Math Lab. Now second table and pick any 2 points. I'm going to stay away from decimals. So I'm going to do negative 4, 3 and negative 2, 2. So let's see, negative 4, 3 would be to the left 4 and up 3, left 4, up 3. And remember, in Math Lab, some of those graphs are tricky. Sometimes the hash marks will go by 2s, or, you know, they'll be really close together or really far apart. So always make sure that when you are plotting this negative 4, 3, that you make sure that up in that rectangle, it shows your cursor is at negative 4, 3. My next point is at negative 2, 2. So left 2, up 2. And since you already told it that you were drawing a line, it'll connect those for you. All right, number 2. Y equals x squared plus 3. Now, the good news is that the y is by itself, so I can take that straight to y equals, okay? This is going to make a different shape, right? Because something else is happening. It's not just an x. It's an x squared. So this is going to give us a different shape than a line. So if you clear it out, there's your x. Then to type it, remember x squared has its own button. After you type in x, you can hit this x squared button. It won't give you another x, it'll just give you a squared exponent. Plus 3. So let's graph it. Because remember, again, the first thing you're going to have to tell MathLab is, oh, this time I'm drawing a U. So you'll pick that U shape, the squared tool. And then I think it makes you do 3 points when you're doing the x squared graph. So let's see, I'll do -1, 4. 0, 3, and 1, 4. So the first point at -1, 4 would be to the left 1 up 4. Zero, 3 would be left and right 0 up 3. And 1, 4. So to the right 1 and up 4. And you know from looking at the graph that that is going to connect and make your U shape. All right, a couple different things about this one. First of all, the y is by itself, so that's good. It's absolute value x this time, so it's going to make a different shape, right? This one's going to make a V. Okay, but even if you don't know that, you'll know it once you put absolute value in your calculator. Now, remember where to find that. I need to figure out how I'm going to give it those absolute value bars. You're going to hit your math button. And then go over right to the num, N-U-M. Once you do that, the first thing under that will say ABS, which is absolute value. So go ahead, since it's already lit up, your cursor's lit up on number 1, hit enter, and that'll give you those absolute value bars that you need. So then inside those absolute value bars, you'll just type in x minus 2. And then get out of the absolute value. So I just go over one to the right. Now I am going to graph this. I like to graph all of them to make sure I can tell MathLab the right shape. So I am going to make a V. Now remember when we did absolute value graphs, that was the only one. It didn't say pick any random points to plot your first point. It made you plot the vertex first. The vertex is the point of that V, right? It's this point right here. So when I'm looking, that it looks like it comes down to the x-axis, touches it, and goes back up, right? When I'm looking at that on the graph, which means if I'm on, that's coming down to where the y is 0. That's going to be its vertex here, right? If I'm on the x-axis, which is where it looks like it comes down to, touches it, and then goes this way. That right there, I'm looking for the y to be 0 when I'm checking my points. So here's my table. I can't even see, it looks like I need, if I'm going to go down, I need to go down. So I'm going to have to do this point first. 2, 0. That's going to be the vertex. That's going to make that point of the V, okay? And then you can pick any other point. So then I'll pick 1, 1, and 3, 1. Yeah, it doesn't matter. Yeah. Are you sure? Oh. Yes. I think it's how I said it. I think I said it kind of confusing. If you are on the x-axis, I saw that I know it's going to come to a V as soon as it hits the x-axis. And where you hit the x-axis is when the y is 0, because y being 0 means that point hadn't gone up or down. That's why it's on the x-axis. It's kind of confusing in there. So my first point is at 2, 0. So to the right 2, up and down 0. That's that vertex. There's a point at 1, 1. So to the right 1, up 1. And then there's another point at 3, 1. So to the right 3, up 1. And again, Math Lab connects it for you after that to draw that V. Okay, we'll just finish this page. We'll do number 4 and number 5, and then we'll wrap this up on Friday. Number 4 gives us a relationship, and it has a list of values in the domain and a list of values in the range. And I'm going to draw the arrows here in just a second. And then it asks me whether or not this correspondence or this relationship is a function or not. Now, remember, the definition of a function is a correspondence in which each value in the domain only corresponds to one value in the range. So looking at this -1 only goes to 2, right? So that value only goes to one number in the range. 1 only goes to 2, which means it's only going to one number in the range. And then the last one, the 8, only goes to the 2. So each value that's listed in the domain only travels to one element in the range. There is only one element in the range, so it couldn't go to multiple numbers because there is only one number over there. So that's why it is a function, because each element in the domain only corresponds to one element in the range. All right, last one for today. Number 5 gives us a function, and then it just gives us 3 numbers to plug in. I feel like we've done this multiple times in multiple different sections for multiple different reasons. This one will just give us this function, f of x equals 3x squared minus 4x. And the first thing it's going to want us to find is f of 0. Which means I just go to this function, and wherever I see an x, I'm going to put a 0 and then do the math. So if I do that, I'll have 3 times 0 squared minus 4 times 0. And then just come up with what that number is. Let's see, 0 squared is still 0. So 0 times 3 is still 0. Minus 4 times 0 is also 0. So that whole thing just turns into 0. The next one says find f of -1. plugging into the same function. So I'm still using the same function. I'm just replacing the x's with negative 1s now. So I have 3 times negative 1 squared minus 4 times negative 1. So let's see here. Negative 1 squared means negative 1 times negative 1. So that actually turns it to positive 1, right? And you have to do this exponent before you do that multiplication. So that really says 3 times 1, which is 3. Then what does this part turn into? You have negative 4 times negative 1, which actually makes it plus 4, which gives me 3 plus 4, which is 7. And the last one says find f of 2. So same function, replacing my x's with 2's. So I have 3 times 2 squared minus 4 times 2. So remember, do your exponent first. You can't multiply 3 times 2. You've got to do 2 squared first. So that really says 3 times 4, which gives you 12. And then negative 4 times 2, so minus 8. And then that 12 minus 8 gives you 4. Okay? Okay, so on Friday, fingers crossed that we will start with number 6, which is exactly like numbers 1, 2, and 3 were. We're just going to be filling out the charts and plotting the points. So that's what we'll start with on Monday. So let's see, I got Davis, Dickey, Devin Deshawn, Bailey Ledoux, Alton Gerald, Bailey again, Abby, and yeah. I'm sorry? Gabriel. Yeah. Okay. Hopefully see y'all Friday. Be careful. Stay safe. Stay healthy.
I didn't know that I was going to be